All right, Dakota, did you understand number 9?
Yes.
Yes. All right, good. Because I thought they gave a few people some issues when I was looking at it. So, all right, so number 9, that's what, f plus g, is it -2?
Yes.
All right, so you have to take f of -2 plus g of -2 from that graph. Well, f of -2 is what is the answer? Well, you don't have anything to plug into, do you? So you have to look at the graph. When I plug in -2 to the f function, if you look at the graph, what y value do you get back? Okay, Dakota, what y value do you get back?
1.
It says 1. All right, when we plug in -2, okay, so you go to the graph, you go to -2, and you see that would be the point -2, 1. All right, g of -2. What do we get for that, Carter?
G of -2.
Yes.
Oh, which question? 9.
9.
G of -2 is 2.
G of -2 is 2. So we add those two together. 1 plus 2 is 3. All right, amuse me. What is f plus g of -3? All right, do it now. What's f plus g of -3? So find f of -3. Find g of -3. Add those two together. Okay. All right. So for f of -3, Andrew, what do we get?
1.
You get 1. G of -3. What do we get, Andrew?
0.
0. So you get 1 plus 0, get 1. All right, good. That's what you should get for that one. Make sure that makes sense. All right, 39. Did the answer they get make sense to you? All right, if you looked at that. So 39. What is the, Marissa, what is the original problem for 39?
F of x equals square root of x minus 1, and g of x equals the square root of 5 minus x.
All right, so you're asked to find the domain of f times g. Then we're asked to find the domain of f divided by g, if I remember right. Okay, for that one. Well, f times g, if you look at that, that's the square root of x minus 1 times the square root of 5 minus x. You don't need to multiply that together. If you don't need to FOIL it, you don't need to do anything like that. You can just leave it just like that. All right, so here's what I'm going to ask you. All right, f times g of 10. Can I do that? F times g of 10. All right, Anthony, why not?
Guess 5 minus 10 gets you negative, and can't negative on the right.
Can't have a negative on a radical. 5 minus 10 doesn't work. So 10 can't be in my domain. How about -3? Can I do f times g of -3? Justin,
No,
why not?
because -3 minus 1 is -4.
-3 minus 1 is -4. It won't work for this one. It'll work for the other one, okay, but not for this one. So here's what you get. You got to know your domain. So for this one here, x minus 1 has to be greater than or equal to 0. 5 minus x has to be greater than or equal to 0 as well. So that means x is greater than or equal to 1 for the first one. So I can use all the numbers bigger than 1. But I'm also restricted by this one. If I add x over, I get 5 is greater than or equal to x, or x is less than or equal to 5. You've got to take both into account. Any number has to work for both of them. So if you think graphically, greater than or equal to 1, less than or equal to 5, has to work where they both work. So that's why we have 1 to 5 is going to be our domain. Okay, 1 to 5 is our domain. Now for division, what's the only thing that changes? Okay, Katie?
The bottom of the fraction can't equal 0.
The denominator cannot equal 0. So that means g, so the square root of 5 minus x. So that means 5 minus x is just greater than 0, which means x is less than 5. And so you'll get the same idea here, except that's an open circle. And so if you look at the answer, it'll say domain is 1 to 5, not including 5. Okay, so you gotta watch that one. Sometimes I think people miss that one a little bit. Okay. All right, questions on the others? Those are the kind of the two ones I wanted to hit. Make sure we were good with those. Make sure you're getting 47 for 46, 48 is 159, plus 69 is 71. Make sure those are correct as well. Anything before we move on? Okay. All right, get out those guided notes. We'll finish those up.
Can I have some?
Yep. You certainly can. All right, we're still on section 2.8. We're going to be on here today. And all right, this is the one we're about halfway down. A little above halfway. We're going to finish this, and then I also have to add one other thing to it. So whether you put that, I don't know if you have room at the bottom to put it on a separate sheet or not. But we do have to do one more thing. All right, fine. F of g of x, and describe the domain of f of g of x. All right, we kind of introduced this composition. This is going to be a little bit more, I guess, the more difficult problems today. We kind of got to some basic ones to introduce the concept. Now these get a little bit messier with the algebra. All right, so f of g of x. All right, do you know how to write it? Well, just your base f of g of x. What's that going to look like? All right, Logan, do you know how to write it?
No.
No. All right, what does this mean? What can you explain here? When I say f of g of x, what do you think in your brain?
The x value has to be substituted in for whatever x is in the equation.
We got to substitute in for the x value, but you actually substitute in, and maybe this is what you meant, but you didn't say. You substitute the whole function in for that x value. So that g of x says, all right, you take the entire function, and you're going to replace x with that. All right, so when I write this 3 and this 1 do not change. This x becomes that. So it becomes 3 over, this x is now 1 over x minus 2 plus 1. So like I said, it just gets a little messier. The concept's the same. You take a whole function, plug it in for an x. But now we're just dealing with a messier concept. You cannot have complex fractions. No complex fractions. Which means, even though this is the step, you cannot leave that as an answer. We've got to simplify it. Complex fraction means you cannot have a fraction within a fraction. Everything has to be a single numerator, single denominator. All right, well, how do I simplify that mess? Okay, so we did in the denominator, you got to get a common denominator. Okay, which is going to be what? What's going to be? So if you want to, you can think of 1 as 1 over 1. So what it has to be in that denominator? It has to be what? X minus 2. So now it becomes 3 over 1 over x minus 2 plus, all right, this is x minus 2. If you add something, you got to make sure you don't change the overall value. So if I add an x minus 2 in the denominator, what do I have to add in the numerator? X minus 2. Since that's just the number 1, you could put a 1 in front of there, but it's not necessary. It's not going to change anything. So now you got 3 over 1 plus x minus 2 over x minus 2. You just add those together. Now, more than likely you'll skip that step and jump to the next one. I don't care, but I just wanted to show it for the notes. This becomes 3 over 1 plus x minus 2 is x minus 1 over x minus 2. All right, so at this point, f of g of x equals 3 over x minus 1 over x minus 2. Can I leave that?
No.
Cannot leave that because it's still a complex fraction. Brooke, you know how to fix it? Brooke says no. Don't know how to fix it. All right, that's why I get paid. All right, this is just a fraction. This is like 6 divided by 3/4. Mrs. Hagner, maybe? Keep, change, flip? Go back. You're going to go in the way back machine. Okay? You use numbers, right? Now we got to use these nasty expressions. Keep, change, flip. Okay, so if I got 6 divided by 3/4, that's 6. Instead of division, we make it,
Multiplication.
and then we do what's the flip mean?
4 is equal to 3 over 4.
Yep, 3 over 4. Now, 6 can be written as 6 over 1. Remember when you multiply straight across. It'd be 24 over 3. It'd become 8. Well, that'd be nice if they were all numbers, but they're not. Here, it's 3. Keep, change, flip. All right, what's that final answer? What's going through your noggin at this point? Carter, anything going through your noggin?
You just simplify it.
And what would that, what steps would you simplify it?
Would it just be 8?
Oh, we're looking at something different. Okay. We're looking at 3 times x minus 2 over x minus 1.
Would it just be that, or would you distribute the 30?
You could do one of 2 things. It just depends upon the situation. You could leave it if you think something will cancel, but the 3 must go in the numerator, or 3x minus 6 over x minus 1. More than likely, you're going to write it as with the distributed. All right, now big thing here. What else did it tell you to find?
The domain.
All right, the domain. The domain's a little bit tricky. I'm going to erase this in a second. How do you find f of g of 4? Let me figure that. Brandon, you know how to find f of g of 4?
Yeah, you plug. So you plug 4 into g of x, and then.
What's that give us? Yep.
So one half there.
1/2, and then we take, what do we do with the 1/2?
And then you plug that into f of x.
Okay, so you get 3 divided by, that'll be 1.5. It's going to end up being 2. Do we get a final answer? Yeah. What can't I plug into g of x? 2. So you cannot plug it. So when you're doing f of g of x, the first thing you need to look at, I'm going to put this over here. G of x equals, was it 1 over x minus 2? X cannot equal 2. So you got to look at what that can't equal. Okay? My final answer, what can't x equal? 1. You have to throw both of those out in the domain. You have to throw both of those out in the domain. So my domain is going to be negative infinity to 1, union 1 to 2, union 2 to infinity. Now, what was f of x, Katie?
3 over x plus 1.
3 over x plus 1. You only need to worry about the first one you're plugging into is a g of x. You're going to think, all right, why can't it equal negative 1? Hopefully somebody thought of that. Why can't it equal negative 1? Well, look what happens. What is f of g of negative 1? Okay. What's g of negative 1? Can I plug that in? Do I get an answer? Negative 1/3, right? So now g of negative 1 is negative 1/3. Can I plug that into the f function? right? Doesn't mean be 0. Well, that gives me what? 3 divided by 2/3, which is, we'll go 9/2. So do I get an answer back when I plug in -1? So it has to be in the domain. Here's where the situation comes into play. We said we can't plug in 1. Take a look at f of g of 1. What's g of 1 equal? G of 1 equals -1. What's f of -1? This is where the -1 gets thrown out. What makes the g function -1? It is +1. So this is now undefined. So you got to be careful here. If it's f of g of x, you got to throw out whatever makes g 0 in the denominator, and then your final answer. If it was reversed, you'd have to take a look at the f of x. All right, let's take a look at that bottom one. Let's take a look at that bottom one. All right, f of x equals 2 to the x power. G of x equals square root of x plus 1. Now, this one isn't as messy in terms of, like, there's not a ton of algebra, but you got to have a good understanding of what's going on. All right, f of g of x. Just how do I write that? Let's just do that. How do I write that? Okay, number one, Hayden Crozier.
It's gonna be f of g of x.
Okay, and what's it going to look like after I replace?
So it's gonna be 2 to the radical x plus 1.
All right, very good. That's all I need to hear from you. That doesn't simplify. You can't do anything else. You're done. Question is, what's its domain? You're substituting in x values into there, and anything I can get an answer back is in the domain. Anything's undefined to throw out. Well, what's your first inclination here on how to handle this? Katie?
So x plus 1 greater than 0.
X plus 1 is greater than, can it equal 0?
Yeah.
Okay, good. So x is greater than or equal to -1. Domain, -1 to infinity. All right, good. All right, take a look at g of f of x. What do you think it's going to look like when you write it out? All right, Adam, what's it going to look like?
It's going to be the square root of 2 to the x plus 1.
Yep, nothing really you can do with that. Just that. Just make sure you write it correctly. Square root of 2 to the x plus 1. All right, domain. Domain. You really got to think about this. Normally, what do we do with the square root? Can't equal what? Or it can't be a
Negative.
Can't be a negative. Can it be 0? So your first inclination is going to be, all right, so 2 to the x plus 1 has to be greater than or equal to 0. You might even do this, 2 to the x greater than or equal to -1. We really don't have the algebra to solve that. Can't take square root, can't take the x root. Okay, we're stuck. Okay, we'll get to that in another chapter. But you can still figure this out. Think about 2 to the x. So here's what you do. Substitute in values. What if x is positive? So there's 3 key sets. There's negatives, 0, and positive. If x is positive, 2 to the first, 2 squared, 2 cubed, is that going to be bigger than -1?
Mm-hmm.
So it's all the positives, right? How about if x is 0? What's 2 to the 0? 1. Is 1 bigger than -1? Yes. What about the negatives? Now here's where you just got to be careless. What is 2 to the -1 equal? 1 over 2. What's 2 to the -2 equal? 1 over 4. Will that ever be a negative number? Will it always be greater than -1? What's our domain? All real numbers. Okay? All real numbers. So we can't get to it algebraically, but we should have the knowledge to figure this out. All real numbers, -infinity to infinity. All right, so this one, not a lot of algebra, but a lot of understanding. Previous one, good bit of algebra. All right, we need to do another one like this because these are hard. Okay, they're a little bit messy. All right, this one isn't on your guide notes. Either put it at the bottom, it will take a little bit of room, or just start on a new sheet of paper. I'll I'll wait for you. I want you, first of all, you got to look at this. This is actually a problem from the book. I'm going to do it two different ways. I'm going to do it the first way and then the second way. Find g of f of x. First thing I want to know is, do you just know how to write that? Then we'll deal with the mess with it. Okay, what does it look like? G of f of x. All right, take a second. All right, Holly, you weren't here yesterday, so I'm gonna put you on the spot. You know how to write it.
Would it be 1 minus x over x plus 2 plus 3?
Okay, so you're gonna take this, which is f of x. Yep, you're right, and you're gonna take it, and you're gonna plug it in for each x. So for the first x, that whole mess, 1 minus x over x plus 2. You still have your plus 3. All right, then what am I gonna get below on the bottom?
1 minus x plus 2 minus 4.
Okay, that x gets taken out. 1 minus x plus 2 minus 4. All right, that's the main thing. If you mess up that part, then the whole thing's blown up. Hopefully you agree with that. All right, there's two directions you can go here. Anna, you got any inclination?
You take 3 and I kind of wrote it out as 3 over 1 and you multiply the x plus 2 to the 3 and 1.
Okay, she's gonna get a common denominator. This is what I was gonna do. Good job. We're gonna get a common denominator for both. Like, we're gonna treat it as two separate problems. Okay, so you got the numerator here, denominator here, and so I got to get the same denominator so to add them together.
Cancel the 1 minus x and the 1 minus x on the numerator and denominator.
No, cannot. Quickest explanation is you can only cancel if everything's written in multiplication, like everything's multiplied together. If you didn't have the plus 3 and you didn't have the minus 4, that would end up working. Okay? But now, because it's going to change. All right, so she says this is like 3 over 1. Agreed, 100%. 1 minus x over x plus 2 plus 3 over 1. But I got to have a denominator of x plus 2. So if I add an x plus 2 to the bottom, I got to add an x plus 2 to the top. Now I'm going to do the same thing in the denominator. I got a 1 minus x over x plus 2 minus 4 over 1, basically adding or introducing an x plus 2 to the bottom of the top. Okay, I got my big fraction. All right, so now I got the same denominator, right? This is going to be 1. I can write it all over x minus 2, and I'm going to take an extra x plus 2. You might be able to do this in quicker. I'm going to take an extra step. I'm going to write this as whatever my numerators are. It's going to be 1 minus x. I'm going to distribute the 3. It's going to be plus 3x plus 6. Same thing in the denominator. I'm going to have my bottom, my second denominator is going to be x plus 2. All right, you really got to watch because you're subtracting there, right? So you really have to distribute a negative 4. So what's going to be up there is going to be a 1 minus x, 1 minus x, minus 4x, and then what? Minus 8, right? So I'm going to combine like terms for both of those numerators. 1 minus x plus 3x plus 6, 2x plus 7, right? Over 2x plus 7 over x plus 2. all over, what is that, negative 5x? Minus 7 over x plus 2. Can I leave that as my answer? It's a complex fraction. Keep, change, flip. So it's really a fraction divided by fraction. Keep the top one, 2x plus 7 over x plus 2 times flip x plus 2 over negative 5x minus 7. Now, you'll notice when we do the keep, change, flip, and some of you might get pretty proficient at it and recognize that if those two denominators are the same, what's going to end up happening to them? Cancel. So they cancel. And what am I left with here? If they don't cancel, you got a FOIL. We don't. Hopefully that doesn't happen. But I end up with 2x plus 7 over negative 5x minus 7. I'm going to ask you the domain. Domain of g of f of x. Okay, we know g of f of x equals 2x plus 7 over negative 5x minus 7. We know that g of x, well, I don't remember what it is, x plus 3 over x minus 4. And I know that f of x equals 1 minus x over x plus 2. All right, I got all the information in. All right, what have I got into there? Oh, Lizzie, you got any ideas on the domain?
The negative infinity to negative 2, then to negative 2 to 4, then 4 to infinity.
Okay, I agree with the first part. We are plugging in numbers into, like if you look at g of f of x and you do plug in 2, you plug in 2 into the f of x. So we got to figure out what that can't equal. Cannot equal 2. Okay, that's the first one we plug into. But we don't look at the g of x, you look at the final answer. What can't x equal for this one? That's going to be what? Positive 7 divided by negative 5. X cannot equal negative 7/5. That should be a negative 2, shouldn't it?
Mm-hmm.
That should be a negative 2. 4 will actually work because I can plug in 4 into here. 1 minus 4 is negative 3 over 6 is negative 1/2, and you plug it into here, you'll get an answer. 4 will work. The second one that won't work is that negative 7/5. So my domain, negative infinity, which one will I come to first? Negative 2, right? Union. Negative 2 to negative 7/5. Union. Negative 7/5 to infinity. Okay. All right, I said I was going to do this one a second way. This one is probably quicker. I don't know if it's easier. It just depends. Depends on how you look at it. Same problem. I'm just going to start with, pay attention, write it down. If that's up to you. But let's take a look at g of f of x. So g of f of x, which is 1 minus x over x plus 2 plus 3 over 1 minus x over x plus 2 minus 4. All right, does anybody have a different way we can do this? Different way. One way we get common denominators, add them all together. Typically, that's what 7 out of 10 people do. Okay. Other way.
Multiply x plus 2 times 3 and then 4, and they cancel out, and then you're left with the same thing, just common denominators.
Say that again.
So what I did, I just multiplied x plus 2 by 3, and then x plus 2 by 4, and then I added up the x minus 1 minus x, the top and the bottom, and then I got the answer.
Okay, I think you're doing it the same way as the other one. I think. But you're kind of on the right track. Get rid of fractions. We can get rid of fractions in one stroke. And maybe this is what you're talking about. What can I multiply both the numerator and the denominator by to get rid of all fractions? I can multiply them both by x plus 2. Okay. What happens when I multiply that times x plus 2? Cancels out the x plus 2's, right? And what's it leave us? 1 minus x. Well, now you got to take 3 times x plus 2. We're not going to get the common denominator. We're just kind of eliminating the denominator. Plus 3 times x plus 2. Well, how's the denominator going to look here? So x plus 2 times this, what's going to happen to the x plus 2's? Cancel, and I'm left with 1 minus x minus 4 times x plus 2. So what it does is it gets rid of that denominator, boom, right away. And so this is going to end up after I distribute 3x, 5x plus 7 over negative 5x minus 7? No. Is that right?
Maybe 2x.
What am I doing wrong here? 3x. Is it 2x plus 7?
Yeah.
Okay, there we go. Okay. So it's quicker. I don't know if it's easier. Just depends on how you look at things. I don't care which way you do it. I really don't. Some people, when they try to do this, just gum it all up and it doesn't go well. All right. So that's your choice. So you can get rid of fractions or you get a common denominator. All right. I did get done a little early, which was my goal. Hey, I want to look at this a little bit closer. The second day you're doing this one, that doesn't mean I'm going to grade it for completeness necessarily, but I might take a closer look at 1 or 2 of them. Make sure you get them right. Oh, and you use the time, whatever time you got. You work till the bell, doing math. You can work with somebody that's absolutely fine. And if you get stuck, ask. EDA 62. All right, good.
This is with $1.